Hello everyone, welcome back. Now in this episode, we are going to dive deep into our AWS Lambda monitoring discussion. Well, if you haven't watched our previous video, we discussed about the overview of it. We discussed about different invocation types and related Lambda monitoring and alarm setup. We discussed about the synchronous invocation, asynchronous invocation, and event source mapping, and some important matrices and alarms that we should set for these type of invocations and the applications developed with these invocation types. So I'll post the link in the description. So if you haven't watched my previous video, go ahead and watch it. And today we are going to continue with and deep dive to synchronous invocation in particular. We are going to look at an example of it, and we will look at the code, serverless configuration, and Lambda configuration, so on and so forth. And also we'll check these type of matrices and alerts: function error rate, duration, concurrent execution, and throttles. So without any further ado, let's get started. I have a small diagram before we jump into the code, which is this one. So the example that we are going to talk about is related to a synchronous invocation, as I already mentioned. And that one is nothing but a simple request response based invocation where we have an API gateway and then Lambda function, and our client, it could be browsers, web mobile application, they will be communicating through HTTP, right? And here let's assume we are requesting some product information. So they will call this API endpoint for that we'll use API gateway. So product/id, product/1 for example, and then API gateway invoke the Lambda function, the products Lambda function. That's going to fetch the data for that particular product and send back to the browser. Here we are not using a Dynamo table, but I have like hardcoded the values in the Lambda itself. Of course, you can easily add a product table as well. So let's see what are the important matrices and alarms that we should have for a synchronous invocation just like this one. Alright, so I have opened Visual Studio Code with the code that I want to discuss with you. So here I'm using serverless framework, and I created a YML or the configuration file called serverless-sync.yml, and here I'm using a plugin like serverless ES build for building, and also Node.js 16x as my runtime for the Lambda function. And I will include the configuration details in the YouTube description. But let me quickly go over the code. And by the way, if you're following along, I also have a gist created for you guys, and there you will find the code as well. I'll put this link also in the description. So we have all the files and the content related to it, including the package JSON and serverless sync YML. Okay, so here I have created a function, and this function is get products by ID. As you have seen, we are fetching the details of a product. Okay, so I have this path product/ID. So ID is a dynamic one, and I can include product/1, 2, 3, 4. The products ID is here, and it's a get method, and it's accepting request parameters. So if you look at the Lambda function code that is there in the get products by ID, and you can find it here in the functions get products by ID. So this is that Lambda code, and as you can see at the beginning I have an array of products, and I'm not like calling a Dynamo or anything. I have hard coded these values in the Lambda itself. So this has like 5 products, product 1, 2, 3, 4, 5, and everything, all the products has an ID, name, description, and the price to it. And then I have this handler function, and this is what Lambda will execute when we trigger it through API gateway. So here we first extract the ID from its path parameters, and then check whether that ID indeed is a number. So we will throw an error if it is not a number. As you can see, I'm throwing an 400 error, and with this error message, invalid request, ID must be numeric. Let's assume that we only expect IDs to be numeric, and we store these IDs for products as numeric. And then we will search the products in that products array with that given ID. And if we have a product, then we are going to return that product. So with the status code of 200 and with that product. But if we don't find a product, then we throw a status code 404 product not found. Now as you can see, in addition to that, I'm introducing a delay here. This is just to simulate some external API calls, Dynamo or the database lookups, and anything else that we need to do, any business logics and so on and so forth. So I can simulate that delay here as well. So that's it, like very simple Lambda function. And let's go ahead and deploy it. So here let me do SLS deploy and -- config, and I'll point to this particular serverless config file, which is serverless sync.yml, and hit enter. So it's getting deployed to US East 2 Ohio region. Now I already deployed it, so there's no any changes, deployment skipped. So if I go to my AWS account, so this is that Lambda function. So get products by ID, and as you can see, this is the API gateway that is triggering it. So if I click in here, I should see the trigger. So this is the API endpoint. So let me just copy this API endpoint, and let's use another tab, and then I will hit enter. But yes, I need to add a proper ID. Now as you can see, I got an error already because earlier my ID was curly braces ID. So yes, so let's use one and hit enter. There we go, I got the product name, description, and pricing. So let's check for product number 2 as well. There we go, I got the product number 2, and 3, it's also there. So I'll try to access product number 6, which is not in my array. So in this case, I should get product not found error. And let's add a string instead of a numeric. Now I get that error as well, invalid request, ID should be numeric. So let's go ahead and check its monitoring tab. Now for AWS Lambda, if you go to AWS Lambda, so let me quickly show you how I get to here. I search AWS Lambda service here and make sure the region that you are in is the one that you deployed, and then you can see your deployed function. So when I click on it, it opens here. And now I can go to the monitor tab, which will show me the default monitoring that we already received with AWS Lambda. Now here we go. Now I already have the invocation, duration, error count and success count, throttles, total, concurrent execution, and several other ones like recursive invocations, async event. But these are probably not relevant to our synchronous invocation, but what we are interested here is these matrices: duration, error count, throttle, and concurrent execution. Now have a look, it has already started generating the duration. So I can expand this, expand it. So this is the duration matrix. So how long it has taken to execute my Lambda function. So let me drill it in the last hour, and this is my execution duration. Okay, now I can see the green color one. Green color one indicates the maximum duration. Can you see? This is the legend for the colors, maximum duration, and this is average duration and the minimum duration. So the minimum duration is set to 0, but average is this part, and this is the maximum duration. And let's have a look. So maximum duration is somewhere around 500 millisecond, because we are adding that 0.5 second delay, and the rest of the things, like it is almost instantly, but you can see 500 millisecond is added. So based on this duration, I can set up some alarm. Now imagine the 500 millisecond delay that we have added is to simulate some external API calls. So what if these external API calls start lagging? And that makes our Lambda function to await for these services, and that will increase the duration. So when we increase the duration, several things happen, right? One is you have to pay more for Lambda execution because execution solely depend on the duration and the memory size that you assign for a Lambda function. So your Lambda cost will increase, and your users have to await, and they have to wait until the response is returned. There's this latency increases, so that's bad for user experience. So you need to be notified, right? So that's what we would probably have an alarm for the duration. And when you're developing applications, you should have some SLAs, service level agreements, or non-functional requirement NFAs, or rather non-functional requirement NFR. So you should set up these values, right? So what is the maximum duration for the Lambda function? What is the the highest latency that you expect from your Lambda functions? If it is more than that, you need to be alerted. Okay, so let's assume that I want to create an alert for this metrics. This is the inbuilt metrics, by the way, so I don't have to create it separately. This is already available to me. I'll go ahead and click view in metrics, this particular button. That will open the CloudWatch metrics. And see, I'm on CloudWatch here, and this is that particular CloudWatch metrics. And I'm going to set alarm for maximum duration. So here I can see this alarm icon, and click create alarm. So the matrix name is duration. I will just call it again maximum duration. So this is the Lambda function, and the statistics is maximum. Period is 1 minute. That's all good. Or I can even set it to last 5 minutes. So during the last 5 minutes was the maximum duration. And then I can click or go to the next one, which is condition. So I have to set up some threshold values. So it's a static threshold, and I'll check whether it's greater than 5 milliseconds. Not millisecond, maybe I'll set 4 seconds. Yes, and then I click next. So if this is in alarm, that means the duration is greater than 4 seconds. I can alert. So easiest way that you can set up an alert is through an SNS topic. You can create an SNS topic, and then here you can select create new SNS topic and give it a name. Product duration alarm topic. And I can insert my email address and create that topic, and then click next, and then save it. So when I do that, I will get an email to my email address. So I have to confirm it. And after that, whenever this function's durations goes beyond 4 seconds, I will receive an email. I'm not going to complete this process, but I think you get the idea. So that's how we set up an alarm for an existing metrics. So let's get back to our Lambda function. So we know about duration now. And the next one is the error rate. Now have a look. If I check the last 3 hours, I will expand it. Let me check last 1 hour here. Now I can see this green color and red color, these lines. And if I look at it, red indicates errors and green indicates success rate. So we don't have any errors because we have caught all the errors and then handle it properly. And the success rate is 100%. Okay. So I can actually go into these metrics and check how these are set up internally. If I expand this detail section, the success rate is calculated with this equation. So it essentially takes into the consideration of all the invocation, and out of that all invocations, how many resulted errors, and then you will minus it or deduct it by 100%. In this case, we don't have any errors, so this part is 0, so 100 minus 0 is 100. This is all good, and I can also see the errors. So it basically checks for any errors. Now here, if I wanted to set up an alarm for errors, you can do that easily. Now here you have the actions. Alarm is here. I'm not sure if this is visible to you guys. However, you should see an alarm icon. Click on it and then proceed with the alarm setting up process, which is pretty much the same which I showed you earlier. So that's error rate, or rather errors and success rate. So let's go back to our dashboards. So we already checked the duration and the error rate. So what about the other two, which is the throttles and the concurrent invocation? So the concurrent invocation, as you can see, there's only one. Now let me zoom it in a little bit. So in the last hour, the maximum concurrency for this particular Lambda function is 1. The total concurrent execution. Why is that? Because we sent the request through the browser. So this is what we have been testing. And if I check 1 and we waited for the result, and then again we check for the second product, we waited for the result, and then we check for the third product, we waited for the results. So every time Lambda returns, and then the next request is served. But what if we will send this request in parallel? So in that case, one Lambda cannot handle all these parallel requests. As you all know, a Lambda function can process one request at a time. Lambda is not designed to process more than one request. So if you want to handle multiple requests, we need to have multiple Lambda invocations. Okay. And let's imagine we will send 3 requests in parallel. Product 1, 2, 3. And then we will have 3 Lambda function invoked in parallel. So then our total concurrency is 3. So let's see if that is the case. I have created a simple script. It says parallel request.js. So here essentially I'm calling this function, and this get products data function, it essentially maintain a list of product IDs 1, 2, 3, 4, 5, and then I'm using Axios to send request in parallel. So I have this promises products id.map. Basically I will map an ID from this list and create axios.get. So I have appended the ID at the end, and then for all these promises I will invoke them in parallel using promise.all. So here I'm going to send 5 requests in parallel to the API gateway, and the API gateway will invoke Lambda functions. So essentially I should see 5 Lambda invocation. So let's see if this is the case. I'm going to run this script. Here you go. I got the results for product 1, 2, 3, 4, 5. I got its name, description, and the price, so on and so forth. So I got all the results, which is good. So let's see how my matrices looks like right now. It will take a minute or so to populate this matrix, but let's see if it has already populated. Let me do a quick refresh here, and I'm particularly interested about this total concurrent execution. But right now I don't see that additional concurrency. Still it shows 1. Probably we have to wait. Okay, look, now when I refresh it, I see now the concurrency is 5. So now that we have sent 5 concurrent requests to API Gateway also invoke 5 Lambda functions, and that's why we see this concurrency count to 5. Now, as you may know, AWS Lambda has different concurrency limits. So if you look at a region, so regional concurrency is somewhere around 1000, right? Well, this depends upon the region. But let's have a look what is the concurrency for this particular region that I'm using, which is Ohio. If I go to these functions or Lambda here, then I should see the full account level concurrency, which is 1000. And out of that 1000, right now I have 1000 unreserved concurrency, because this is one of my test accounts. So I don't have any production workloads or anything happening or running right now. And at the moment, there are no any Lambda functions running. So the unreserved concurrency is 1000. So earlier when we run the script, we had 5 concurrent Lambda functions. So meaning that at that time, this account level concurrency is 995. Okay. Now imagine we have 1000 requests coming into this Lambda function in parallel. So then the total concurrency is 1000. So the unreserved concurrency in that case should be 0. So at that point, if there's another Lambda functions trying to get invoked, it doesn't have to be the exact this Lambda function, but another Lambda function, it won't invoke. It's going to throttle because there are no any unreserved concurrency for this particular region. So that's one thing. And the next one is, if you have like so many concurrent Lambda functions, meaning that all these Lambda functions like invoke in parallel. Now, if this Lambda function is calling out to another third-party API also, let's say we have a third-party API, and all these Lambda function, they are making requests to it. So now we have, let's say, 1000 concurrent Lambda function, and we will send 1000 requests to this particular third-party API, which we don't manage. So this API could throttle after, let's say, 5 requests in concurrent request. Then if we send like more than 5 requests, then it's going to either throw an error or so. So this is another reason why we probably need to be aware about how many concurrent Lambda execution, and that's where we would set up an alarm. Now, in addition to account concurrency, we have another one called burst concurrency. Now, this essentially means how many Lambda function can AWS Lambda service invoke immediately. So let's say we have 1000 parallel requests. So instantly, how many Lambda functions can be invoked in parallel? Although the account level concurrency and unreserved concurrency is 1000, where we can cater for those 1000 requests, there are limits for burst concurrency, meaning that instantly we can have up to, let's say, 300 Lambda functions invoked instantly. But now we need more Lambda invocation. There's another 700. So it takes some time, a minute or so to warm up, or we can call it warm up, and then it will invoke another number of Lambda functions, let's say another 300 or 500. So this is the burst concurrency, how much burst that Lambda can support. And this is kind of a hard limit per region, so you have to be aware of it. So that's where we need to set up some alarms for concurrency. And you know how to do that already. You can go to the corresponding metrics and set up an alarm. Yeah, click view metrics, and then it will open the metrics board, and then you can set up an alarm. Now, in addition to an alarm, you can again set up a ceiling for these concurrent executions. Ceiling as in, you can say this particular Lambda function can have maximum of, let's say, 10 concurrent executions. So when you set up a ceiling, and we set up a ceiling using something called reserved concurrency. So when you set up a reserved concurrency for a Lambda function, the concurrent Lambda invocation don't go beyond that. For example, I can set the reserved concurrency to 1. Let me do that. I'll go to the configuration section, and then I'll select concurrency. Now here in the concurrency section, so right now I'm using full unreserved concurrency, which means like at the moment I have 1000 unreserved concurrency. This Lambda function can have up to 1000 concurrency. But let's change that. I'll click edit, and I'm going to use reserved concurrency. I'll set the reserved concurrency to 1 and hit save. By the way, you should be careful about this reserved concurrency. Now that I have set reserved concurrency, although I have 1000 unreserved at the account level, this Lambda function will only reserve or can go only up to one concurrent invocation. So usually when we apply this reserved concurrency to your production application, we usually do a performance test, and with the performance test we will see how much concurrency requirement a particular Lambda function need, and then we will have another buffer to it and then set the reserved concurrency. So now I will go ahead and then run the same script. Now I'm sending another 5 parallel requests. So this time I should reserve an error. Look, API error. Let me do it again. I get the same error. So now that I set it to reserved concurrency, the Lambda is going to throttle. Now if I go to the monitoring section, that's the next metrics, you should set some alarm. I should see some throttling. Let's do a refresh couple of times. Now have a look. I see there's a throttling and 4 of my Lambda invocations are throttled. Why 4? Because I set reserved concurrency to 1. So one Lambda function executed properly, but the other 4 got throttled. So that's why you should have an alarm for these throttles. So whenever there's a throttle occurred, you can get notified and then attend to it. Alright, so this is what I want to show you in this video. So we covered the important matrices that you should set up for your synchronous invocation. So in the next videos, we are going to look at matrices and alarms that you should set for asynchronous invocation and event source mapping. I'll see you in the next video.